Dear student, we have completed the 1.5 module for first internals. The remaining portion we will going to complete in the video lecturing. So in that second module is corrosion and metal finishing. In that corrosion, we have studied the meaning of corrosion, definitions and protection of the corrosions, also including types. In that definition for corrosion is the metal or alloys destroyed by the environment through chemical or electrochemical changes, we call it as corrosion. As the same way for the protection also, the coating of metals, the coating of non-metals, the coating of organic compounds also, we have three types of coatings are there. Out of that, first one we have studied, that is galvanization, coating of zinc on iron. Second one is development of the oxide layer on the metal. We call it as anodization. Third one is painting and other varnishes supplying is also there. That is not in the syllabus. So we have discussed in these two. One is coating of metal. Another one is anodizing. So this is also nothing but coatings of changing the surface characteristic features. But after few days, it is going to reduce its characteristic features either by peeling of the coating metal or by the it has stopped by it is attacked by the corrosion also. But in the metal finishing is extended portion of the metal coating. In that, for the definition is also of course a little bit of coincide or matching with the corrosion control also. The definition for metal finishing is the coating of metal or alloys or oxides of metal or any other inorganic components or compounds or even these non-metals, polymers also coating on the substrate. In such a process, in this process, the modification of the characteristic features of surface of base metal, we call it as metal finishing. I repeat the definition. Here also this coating of metals, non-metals or even any metal oxides or even polymers also on the base. In such a process, modify the surface characteristic features of the base metal without changing of its internal structure. So it means modification. It is nothing but a permanent changing has taken place. So far, we have option to the more better to the metal coating is metal finishing. So don't feel it is metal finishing means not cutting, repolishing or polishing or we can brightening of the metals is not. It is also a coating, but it is completely modify the surface characteristic feature. So for that we have used the number of methods. Out of that, the university has prescribed the two methods. Those are electroplating and electroless plating. So in this, before going to this explaining the methods of electroplating and electroless plating, so for this metal coating to the another metal is only the first part of the second module is corrosion. So for metal finishing, not only purpose, not only technological importance for coating of the metal on the base metal, the number of other importance are there. Those are, we call it as a technological importance. In that, first one is to impart the decorative purposes. For example, you take the idea of the copper. It can coated by silver. It can coated by gold also. It can coated by platinum also. So in this, 1 or 2 weeks or 1 or 2 months, it is not removed. So it is too long. It is saving up. So that is what we call it as a modify the surface characteristic feature. Second importance is corrosion resistance, to impart the corrosion resistance. Third one is to impart the light resistance, to impart making the thermal resistance, to making the conductance increasing of higher temperature also, to making in the conductance for lower temperature also we can doing. For to impart of preparation or modifications of electro components, that is electroless component. In this examples are we have taken into as electrical components and electronic components. as the same way to impart of this electrophoresis, in that we can use it also, the changing of completely the outer surface characteristic features to make it itching. So make it outer surface is wear and tear resistance. In that itching, the upper surface is bulging. The inner surface is also same it as in the surface manner also, not in the concave, or even make it concave is also, it is look like a permanent. Of course it is permanent also, that is we can call it as itching. So followed by we can using of other is electro printed board PCB also, that is we can do it. So like this number of 8 to 10 or 25 also we can increase us. But in the question what we are asking for 6 marks, define metal finishing, what are its technical importance? 2 plus 4 marks. For 4 you can write 8 options you will going to write. So one point for half marks. So far you can write it. So these are technological importance. The definition of the metal finishing is wow. So next is types of the metal finishing. So in these types of the metal finishing, already we have given this number of methods also there. So in that electroplating is there and electroless plating is there. In that method electroplating, the coating of the metal on the substrate by electrolysis. Here what is the meaning of electrolysis? The decomposition of the compounds into its constituents by electricity, we can call it as electrolysis. So far, the coating of the metal on the base metal using the electricity, the complete decomposition of the compound and into as applied or coating on the base metal, we can call it as electroplating. So repeat the definition for this is what we call it as the coating of metal on the substrate by electrolysis. We can call it as electroplating. For this, one example is the coating of chromium on the base metal. Second method is we have to follow the prescribed university is electroless plating. Electroless plating example is electroless plating of copper and electroless plating of nickel. So in this electroless plating definition is the coating of metal from its ions in the presence of reducing agent without using the electricity. We can call it as electroless plating. Here less means without the electricity, presence of reducing agents, we can do it. That is what we call it as electroless plating. So before starting off electroplating and electroless plating, we have to follow some of the very strict calculations, theoretical calculations, what we can call it as this is principles of electroplating, principles of metal finishing. Those are, number 1 is polarization of the electrode, second one decomposition potential, third one is lower voltage. So it is there in the notes, for these 3 principles we have described along with the 3 diagrams. You can open the notes of 3 diagrams in the notes and you can go into study. Before to that you have to listen. So what you can understanding in the differential metal corrosion, taking one container, so taking one aerated solution sodium chloride in that, 2 metal pieces are inserted, they are connected, it is internally, of course it is 2 are partially dipped, of course it is outer surface is connected by, or you can keep aside also, or connected with any wire also. Example is one is Zn, another one is copper. Out of these 2 metals, one is acted as anode, that is zinc. Copper is acted as cathode. Which one is acted as anode? Anodic reaction takes place, that is what we can call it as anodic itself. It is not a corrosion, but it is starting, initiation anode which is acted as anode suffering from corrosion, which is acted as non-suffering, not affected by corrosion. So far, zinc is affected, loss of electron, the drift of movement of the electron from the anode to the cathode. How many electrons are drifted from the anode? So in that number of electron is absorbed from the solution. So this polarization is nothing but electrode phenomena. When we are using it is electrode phenomena or electrode potential, immediately already we have studied one formula, that is Nernst equation. I think all of you know about this. E is equal to E naught plus 0.0591 divided by N into log of Mn plus. I think you have discussed the difference between plus and minus is also. We can going to change at the time of log Mn plus. It is plus symbol. So it is, if you 1 by log Mn plus E, we can call it as minus symbol. We have used. From this we can find out the electrode potential basis. We have to applying of this coating of the metal. But we should know the electrode potential of given metal, that is coating metal. So in this, what is you can understanding? So you can connect it externally, internally. So it is partially dipped. Automatically the number of flowing of electrons from anode to the cathode. So it is that we call it as a not polarized or unpolarized. You make it slow. You make it slow. The rate of flowing of electron from anode to the cathode, you can reduce. You can applying of some corrosion resistant to the plating bath also, and other methods also there. So in that, what we are doing, the slow supply of electrons from the region of higher concentration, from the region of its solution to the surface of the electrode, we can call it as a polarization of electrode. So what we are doing is, so one electron is coming in this rate of too much I, you can reduce. On what basis? You can applying something to that. So it's slow supplying to the surface. One electron is passing from anode to the cathode, you take 1 second, it may take 2 seconds, or it may take 10 seconds. But at the time, we are calling as it is polarized. Or hundreds of electrons is passing from anode to the cathode within a fraction of a second, it is unpolarized. So far, the definition is the slow supply of electrons from the bulk region to the surface of the metal, to the surface of the anode, we can call it as a polarization of the electrode. Otherwise, it is what you can do, the coating of metal has taken place. Instead of the metal finishing, the coating of metal takes place. After very few days, it is peeling off also, or it is attacked by the corrosion also. And this, what is we can using the definition, modify the surface characteristic, it has not done also. So far, first principle is slow supply of electron to the on the surface from the bulk region of the solutions, we can call it as a polarization of electrode. You can calculate and you will do it also. The second one is a decomposition potential. For this, what you can do, so same that two dipped electrodes in that one aerated sodium chloride solution, in between connected one ammeter also. For the, you complete the circuit, you can take one contactor also. That is one word we can as a Fogan drift. We can use that. So that components we have used also. Take 1 or 2 meters. 2 meters of sleeved wire. So it is not covering by any of the insulations. You have take it. One taking one wooden bridge also connected to that. This contactor is moving from left hand to the right hand side. So left hand is mentioned as A, right hand side of that wire is mentioned as B. So in that, so completely it is connected to the anode is connected to the battery of the anode, and cathode is connected to the battery of the cathode. This diagram is there in the notes, you can go and see it. So then you can using of that contactor circuit is completed, that is using the switch also. Switch on to that, then it is you moving that contactor from side A to side B. When you keep it that contactor on the side A, so at the time no voltage as applied. You moving off 1 millimeter or 1 centimeter, so 0.1 is applied, 0.1 volt. You moving towards 2 centimeter, 0.2 volt is applied. You moving 3.3 is applied. So as same as followed up to you 0.1 meter, so 1 volt as applied. So that this electrolysis has not decomposed. This electrical compound is not decomposed. So it is moving on. It is come to the 1.7. At the time start to the decomposition of compound. That is we can call it as through electrolysis. So this is we can call it as decomposition potential. So in this one definition is it is minimum voltage must be applied to bring the continuous electrolysis of an electrolyte. So once it has started, afterwards it should not stop. That potential we can call it as a electrode potential. Sorry, this is decomposition potential. Name itself indicates decomposition, composition, decomposition. That is, compound is dissociated into its components. Afterwards, it coating up. Anions go to coating on the anode, cations go to the coating on the cathode. This has taken place by this definition. So repeat this definition. The complete and decomposition of compounds by continuous supply of electrolysis of minimum supply. It must be applied minimum potential for continuous electrolysis of an electrolyte is decomposition potential. So theoretically we have calculated 1.7 volt and also applied the 1.7 volt also. It is completely electrolysis taken place. This is no problem. This is also we can calculate it and we will do it. So what is the next one is the third one is over voltage. So of course it is show it in the graph also. Same you can calculate in 1.7 volt also. But in theoretically 1.7 volt the contactor is moving from 0 to the 1.7 meter. At the time it has not electrolyzed. It has not decomposed. At the time you take 1.75 or 1.8. At that time it is start to continuous electrolysis of an electrolyte. So this instead of 1.7 raised to 1.8, this 0.1 is over voltage. So what is the definition for this? The decomposition potential is above the theoretical decomposition potential, taking the extra potential for the complete decomposition of electrolyte by excess voltage. We can call it as a over voltage. The definition is the excess voltage has to be applied above the theoretical decomposition potential for continuous electrolysis of an electrolyte. We can call it as a over voltage. For any one of this, coating of chromium or coating of iron or coating of zinc, coating of tin, coating of silver, coating of any metals or any non-metal, you should know their electrode potential, you should know their, that is, decomposition potential, you should know their over voltage. Everything should be calculated and you have to starting off a metal finishing. Otherwise, only coating, it should not modify the surface characteristic features. For this also, that coating is changing into a metal finishing by number of other characteristic features. Those are, number one is nature of electrodes. It is nothing but electrode potential, concentration of the electrolyte. How much is required? Not too much of concentration or not too less concentration. The optimum concentration, that is also calculated based on the molecular weight of the electrolytes. You can calculate, and that much of mole is you can use it. Third one is you can maintain the pH also as the same. Fourth one you can maintain the temperature also. Fifth one you can maintaining of rating of stirring also you have to do it. So these are other characteristic features made the instead of coating metal into the metal finishing. For any of the metal finishing, whether it is electroplating or electroless plating, electrophoresis or any other these metal finishing methods, you have to follow these 3-4 principles are must be necessary. To stop now.
Start.
In that, what we can, so these principles we have to follow. So first one is we have to starting off that is electroplating of chromium. Already you know the definition. The coating of metal on the substrate by electrolysis we can call it as electroplating. So here what is the chromium is coating on the either aluminum or either iron or either any metal you will take, no problem. So this what is to be coated metal or base metal, you should be connected to the cathode of the battery. So that is acted as a cathode. So which is a coating metal, you should take it into as anode. In that case, chromium coating of chromium, you don't take it as chromium metal. Instead of the metal, plumbium oxide is coating by chromium or stainless steel you will take. For this, it has little bit changing of methodology. So what is its containing of the plates, that is plating bath, little bit is different. So far, we are making this anode is instead of the chromium, you will take it as a stainless steel. Then it is a composition of the plating bath. In that, 100% of, you will take 1 liter of chromic acid, H2Cr2O4. You will take either 1 liter or 2 liter. You will take it into as a one of the container. We can call it for electroprocessing, that is plating bath. That is we call it as a bath. You can add 1% of concentrated H2SO4 you should be added. Then you will considerations of it is polarization, everything you have to calculate. Afterwards you can start to this it is coating of chromium we have used for 2 purposes. One is decorative purposes, another one is it is using for hard chrome. Let's make it a surface is hard, so making the surface completely going to changing into the hard. Everything we have to be set up for first for decorative purposes. You can using the switch on complete the circuit. The to be coated metal is before connected to the cathode. You should be using the term is pre-treated. What is this meaning of pre-treated? It is first you can removing of any impurities are there by mechanical process. Then it is you can dip it into this H2SO4 we can call it as pickling. Then it is you can dip it into this any organic solvents we can call it as degreasing. Afterwards you can dip it into this flux. So zinc and ammonium chloride is you can dip it into that. So almost all its surface is 100% free from any type of the impurities. Of course, you can apply it to the flame test also. Then you will connect it to the cathode of the battery and it is dipped into the plating bath. Afterwards, you can switch this minimum supply. Current density also should be calculated. It is very less density of current you can apply. It can taking the more time. At the time is coating should be metal finishing. It is a strip, brighten and strength, hard. Everything is has to be taken place. If you raise the volt, it reverses to that. Instead of the metal finishing, the metal coating has to be taken place. That is loose and powdery and immediately no brightness. After 1 or 2 days or week also you can rub by your hand also. It can remove. That is, it is coating of metal. So far, you can calculate its voltage. Very minimum 1 volt or 2 volt you can select it. For this chromium, you have taken the 100% of 100 is to 1 of chromium acid as well as H2SO4. You mix it and added 0.3 volt. Start to applying of 0.3 volt. Then continuous electrolysis of this chromium oxide, that is chromate ions becoming as chromium ions. The chromium ions start to coating on the base metal, that is on the cathode. It will take the time. So based on the size of the component, that is substrate, it will going on. Finally, you can stop it. When this coating of chromium on the cathode, you can stop it. This is only at the time we have used 10 to 20% of the efficiency. If you are having the battery is 1 volt or 2 volt or 5 volt, any volt is having just a 10% of efficiency. 10 to 15% is used. That metal is using for decorative purposes. If you want to make it for any of the piston preparation, or this we can call it as a piston and ring, and any of these piston rods, too much of strengthen have to give this surface characteristic feature. At the time, the current efficiency raised to the 20 to 40%. Instead of the 0.3 volt, you can raise to the 0.5 or 6 volt. At the time also, it is starting of this chromium on the cathode, but the decorative purposes is using just look like of metal of iron. This is acting as a chromium metal, completely coated. We can use it for any odd type of the purposes. This surface characteristic feature is completely changed. So that is modified. So from this, what we can understand, the calculation of, follow the principles, calculation of nature of the metals, calculation of this, calculation of mole of the substances also, calculate the plating bath capacity also, that is throwing power. Everything is calculated. So then it is starting. So within shape and size and as well as the nature of this electrode also, the coating as completed. That is, we can call it as a metal finishing. So in this, so only for two types, one is decorative purposes, another one is a hard purposes. Hard purposes, increasing the voltage. For decorative purposes, you can decrease 10% of efficiency. This is 20 to 30% of the efficiency. In this, chromic acid is ionized. Chromium ion has taken place. Again, it is dissolved in the water. That is, dichromate has formed. So, dichromic acid. Then it is dissociated into dichromics as the chromium ions getting off electrons from this electrolyte. Then that chromium is coated on the base metal, that is substrate. So one question is there, why not using as anode of this chromium? Because it is too much of fuzziness. Suppose you are using the chromium metal, so instead of the bright colored chromium as coating, the black will be coating. And as well as we are using this chromic acid, so it is passive as well as supposed to coating black as form. Many of the times not coated, and supposed to coated black color will form. So far, this is coating of chromium on the base metal for both the purpose. One for using less potential, that is less percentage, that is decorative. More electricity, we can use it as hard chromium.